Okay, so if you haven't already found it, okay, the position versus time graphing lab is the one we're working on, and this is the file you want to have open, okay, the Google Doc. That is your lab report template. Okay, the way that labs will work in this course at least is that you will always get this from me. It's the skeleton for the lab. You just have to, you know, fill in the fleshy part, okay, and then it's all good from there. So what I will do this morning, and for every lab, is I will kind of outline some things, give you some pretty big juicy hints and stuff about what, you know, to put in your hypothesis and what kinds of things I'm looking for. I make the expectations very, very clear for what I'm looking for on the lab report. So if you're paying attention, or if you go back and listen to the recording of me giving all the hints and stuff while you're doing the lab report, good idea by the way, okay, it's always pretty easy to do well on the lab reports. I mean, after all, this is where you're practicing the skills that you're supposed to acquire, okay, at least the lab portion of it for the course. So I try and make that as clear and easy as possible for you to do, okay? So you need to have that open and be typing away in there because I'll give you some pretty big juicy hints for quite a bit of this. So the purpose of the lab today is we want to use a position versus time graph to calculate the velocity of two different toy carts. Okay, so the way that we're going to do that is we're going to have these little Pasco Scientific carts. Okay, they communicate via Bluetooth to your phone, to the app, that SparkView app I told you to put on your phone last week. Okay, so what they will do is while they are rolling, okay, they send out data about their position, their velocity, their angular, like it records a whole bunch of stuff we don't need. We're only going to actually need the position data and the time data, and we're going to have to delete basically everything else, but that's fine. I'll show you how to do that later. Okay, the point is they're going to send all the data you need to your phone, and then you're just going to copy and paste it, okay, into Google Sheets. In fact, it'll make a Google Sheet almost for you, so it makes your life really, really easy. Okay, and then we'll be able to get our data from there. Okay, everybody with me there? So we're going to do two trials. Okay, and all we're going to do is we're just going to give the cart a little push. Okay, and then while it's in kind of this portion of the track and traveling at a fairly constant velocity, we're going to record the data. Okay, on the second trial, we'll give it a slightly harder push. Okay, just so that we get a slightly different velocity on the second trial. Okay, everybody with me there? I'll get into the nitty-gritty of that later. Also, by the way, watch out because there is a little plunger thing here that we use for a momentum lab, and if you press this little black button, it will surprise you like it surprised me. Okay, even though I've seen this happen so many times. Okay, so just be aware of that. You don't need that for anything, and it's probably best if it's like already out when you're doing the lab. Also, on the carts, you will see on the top here an X, Y, and Z coordinate system. Okay, that means that this side is the front. Okay, the side with the plunger is the back. If you run it the wrong way, it will tell you your cart is going backwards. Why? Because your cart is going backwards. Okay, so you don't want that. You want your data to look like this, not like this. Okay, you'll know right away if you have it backwards. Okay. Other thing, in terms of preserving the equipment, these are $400 each. So please, we're going to do this lab on the floor, not on the desk like I have it right now. Okay, and when you are not using the cart, do not set it on your desk. Your desk is not level, and it will roll off, and then it will shatter. And then there will be anger. No violence, but anger. Okay? So just be aware that these are very expensive. We need to treat them carefully. So what I always say is when you're not using it, set it on its top so the wheels are up and it can't roll anywhere. Okay? All right. So the problem we're investigating, how can the speeds of two different toy carts be determined? You need to put that in your own words in the form of a question. That's all that I expect for the problem. Okay, how can we calculate the velocity of the car? Whatever, just put it in your own words. Okay, and you might want to say using a position time graph, some mention of position time graph. That's after all what the lab is about. Okay, our variables. Okay, for this lab, sometimes it can be confusing because we're doing two trials, and lots of times people will say the speed of the cart is the manipulated variable, but in this case, it is not. Okay, we're simply doing two different trials, and during those trials, the velocity of the cart is constant. Okay, and anything that's constant throughout a trial is what kind of a variable? Controlled, yeah. Okay, so I'm giving you one of your controlled variables right now. The velocity of the cart is actually a controlled variable. It's being kept the same throughout each trial, okay, by essentially making sure that the cart can't accelerate. Okay, we're not making a ramp, or we're using a flat surface. Okay, we're not providing power for it to continue accelerating or anything like that. Okay, now what I'm looking for with the variables is this, that you identify the variable and explain how and why. So for the velocity one as an example, okay, you would identify velocity as a controlled variable. The velocity is being controlled by the experimenter by ensuring the track the cart travels on is level. This is important, or this has to be controlled, because the shape of the graph would not be desirable if it was accelerating. Okay, so you tell me how it's being controlled and why it's being controlled. Okay, and the same goes for the other variables. How it's being manipulated, why it's being manipulated. Okay, how it's responding, why it's responding. Okay, so there's always a how and a why in your explanation. So each variable is going to be, at least a couple of lines of text for your identification and explanation. People always forget to do the explanation part, okay, and it's a big deal. 5 marks out of the 30 marks for this lab are the variables. If you don't explain them, the best you can hope for is like 2 out of 5. Okay, so make sure you explain as well. All right, in this lab, we are going to be making position versus time graphs. Okay, and on a position versus time graph, what variable, or on any graph for that matter, what variable, manipulated or responding, goes on the x-axis?
Time.
Okay, time's going to be on the x-axis because it's the what variable?
Responding.
It's the independent or manipulated variable. Okay, time is going here. Time, and I know that sounds weird. People sometimes have trouble getting their head around how time. I'm manipulating time. Whoa! I just thought this was like physics 20. How are we already into that? Okay, we're not manipulating time. We're not making it run faster, slower, or backwards. Okay, we're controlling, or we're manipulating time by essentially fixing the length of the experiment. Okay, we determine when the experiment starts and ends. That way, we're manipulating the time allowed for the cart to travel. You may have noticed I just gave you everything you needed for identification and explanation of the manipulated variable. Okay, so time is the manipulated variable because the experimenter is determining the length of time the cart is allowed to travel. That will influence the distance the cart can travel. Okay, are you getting an idea for the level of detail I'm looking for here? Okay. All right, so our responding variable then is the thing we're watching, the thing we're measuring, okay? The thing that we're hoping will change. What's the other part of this graph? Position. All right, so there it is. I've given it to you, but I'm not going to give you the explanation. You've got to explain to me how and why the position of the cart is going to change in this experiment. Okay. All right. Our hypothesis should always contain 3 words. What 3 words are they?
If, then, because.
Okay, if, then, and I usually say if, and then.
Oh, yeah.
Yes, okay, but good. Okay, so if, and then. The if part is basically the premise that we're working on in the experiment, okay? So in this case, we could talk about the relationship between position and time for an object traveling at a constant velocity. Okay, so if in the if part we would talk about what that looks like. If an object is traveling at a constant velocity, okay, what does the graph look like? Okay, the graph, you know, or you don't have to say that in the if part, but you have to talk to me about the relationship they have. Okay, does position change by the same amount every time interval? Okay, things like that. So you're looking at a linear relationship. So in the if part, you could talk about that. You could say if there's a linear relationship, blah blah blah. Okay, the and part of a hypothesis always describes the experiment very briefly. Okay, so for the and part for this experiment, it could simply be and a cart is allowed to travel at a constant velocity for a short period of time while position is recorded. Done. That's what we're doing. Okay, that's a very brief description of the experiment. Okay, and the then part kind of has to tell me what you're going to get. Okay, the then part always predicts your results. Okay, so the if part is your premise, what you think is true. The and part describes how you're going to test that. And the then part predicts your results or tells me what you're going to be able to do with your data. In this case, okay, you should probably tell me what your graph will look like, and most importantly, in the then part, okay, how you will calculate speed, or sorry, velocity, using your graph. And specifically, I would say you probably need to talk about this. Okay, maybe what part of that equation would represent the velocity of the cart. Okay, something along those lines. Okay, because that's telling me here's what the data is going to be, and here's how I can use it to get what I want. All right. Okay, so the if part, if there's a linear relationship, talk about the relationship. Okay, the and part, describe the experiment. The then part, what's your graph going to look like, and how will you get velocity? Okay. Okay, so the procedure, I thought I had changed the picture, but I guess I didn't. So I've already kind of shown you how this is going to work, okay, with the cart. So here's how the data gets collected. Okay, you're going to first open up your SparkView app. Okay, so the one you put on your phone last week. Okay, and it always goes straight to landscape, but in this case, I'm going to go to the initial screen. Okay, no, I don't want to help SparkView. Okay, so it's going to give you this screen initially. It's going to say choose a path. Okay, and what you want to do is choose sensor data, which is the middle button. Okay, you'll get this screen here. All right, now on the far left-hand corner, there's a Bluetooth symbol. Okay, you're going to want to press that, and it'll show you a list of all the Bluetooth-capable carts in the area. Okay, so you got to have your cart on. Okay, so there's a little power button right there. Okay, turn it on. The Bluetooth light will flash red. Okay, and then you will see show up in here smart cart, and then there's some numbers and color. We have red and blue carts. Okay, so I've got a blue cart, and my cart number is written right here. It's 364050. That's, of course, the only one that's on right now, so it's the one that's showing up. You do need to make sure you connect to your cart, okay, because otherwise you're going to really mess up somebody else. Okay, only one person can connect to a cart. Don't try to connect everybody's phone to the cart in the group, because it won't do that. Okay, it can only connect to one phone. So one person is going to be in charge of collecting your data. Okay, so I'm going to connect to the cart just by selecting it. It's going to say connecting. Eventually, there we go. All right, so now it's connected, and it gives me some options for what it wants, what I want to have displayed while the experiment is going on. All right, so right now, I'm just going to want to show position. So I'm just going, there's a little thing that says position. It's got a check mark in it by default. Leave it that way. Okay, it's going to record everything, but it's only going to show you the position on the screen. Okay, and that's what we want. So once I've got that selected, then I'm going to hit the top left graph. Okay, hit that, and it'll give me my data, and it'll be ready to go. There's a little green button at the bottom. That's the start button. Okay, once you start that, there is a delay. Okay, because what usually happens is people get this thing all set up, and they're like, okay, and they press the button, they're like, go! And the person gets the cart moving, and just as they stop the cart, the thing finally starts to record data. Okay, so you kind of have to do this, and that's why it's like actually possible to do this with just one person. Okay, I press start, I wait till I see recording, I give my cart a push, I stop my cart, I stop my data. Okay, now I've got a little extra data on there, is that okay? Yeah, because in Google Sheets, I'm just going to take that stuff off. I only want the part that's diagonal. Okay, so I'll take that stuff off, and I'll show you how to do that. Okay, here in a minute. All right, so we're just going to do two trials. So I gave that one kind of a light push, okay, and then on the second one, I'm going to give it a harder push. All right, so I'll hit end. So you don't have to clear anything. If you hit start again, it'll record a second set of data. You don't have to worry about that. Okay, so I'm just going to hit start again. Okay, I see data. Okay. Stop. Now it only shows one at a time, okay, and so I can just see that my second set of data is there. Okay, now I'm good. I've got all the data I need. All right. How long did collecting the data take me? Like, I was explaining how to do it, and it took me 2 minutes. Okay, so it's not a big part of the lab. It's not going to be really time consuming. Right. After that, you're just going to share it with your group. So once your group has your data, okay, have the person with the phone come to me and I'll show you how to share the data. You will all need to enter your school emails in so that it can be emailed to you, okay, or shared on Google Drive, whichever you're more comfortable with. But just have the person who has the data come see me when you've collected your data. If you have a trial that doesn't work, don't worry about it. Just remember what number it is and we'll delete it later. Okay, we can't delete it within the app. Okay? All right, questions? I'm not even going to talk about the analysis until we have data. Okay, so let's collect the data now. So every group needs a track and a cart. Okay, let's say groups of like 4, okay, maybe 5, but let's not get bigger than 5 because otherwise there's lots of people with nothing to do. Okay, so groups of like 4. Okay, there's lots of carts. Okay, a group can have this set. I will disconnect from the cart so that it works. Okay, and let's get to it. Okay, if you can just try and include everybody, make sure everybody's got a group here. So if you got that emailed to you, okay, obviously you'll need to open your school email. Okay. Okay, and so I just emailed it to myself. Okay, so I can just go in here, and it's going to be called, probably, unless you actually change the name yourself, going to be called exported data, and it's a comma separated values. So when you try and open it, it's going to do something weird. Okay, which is this. It's going to open it like this, but it's going to give you this option, open with Google Sheets, which is what you want to do. Okay, and then it'll convert it to a Google Sheet, and then we can go from there. Okay, so when it does that, obviously there's a lot here, like way, way more than we need. All right, so what we're going to do is we're going to delete everything except the time for your longest run. So that would be the slowest cart. Okay, and the position values for the 2 runs you're keeping. Okay, so to delete stuff, okay, just look in here. It'll tell you what it's for, right? It says force, run 1, acceleration. We don't want any of that. Okay, we don't need even the date and the time. So, right, we just want to delete that column. Okay, we're going to delete this column. If I was on my computer, this would be faster, but because I could highlight a whole bunch at once. But okay, then delete that column. Okay, and okay, delete those columns. All right, so now I'm down to, I've got my time for run 1, and I've got my position for run 1. Okay, they're side by side. Now I want to keep deleting stuff, okay, until I get rid of all the other junk I don't want. Okay, so that would be the velocity stuff, the acceleration stuff, the date and time for run 1, or for run 2. Okay, so delete those columns. Okay, and I also want to delete the time for run 2. And I want to delete all these ones up to position, so. Okay, and then I'm going to get rid of all the rest of it here. Okay, now, there's going to be one issue if you get to this point and leave it this way. And that is that without having columns all the way along the screen, when you make your graph, it does some weird things. So what I usually do at this point is I just insert a bunch of columns that are blank, okay, and then I've got it all the way to the end. Okay, so. Okay, so just keep inserting columns until you got it kind of full. Okay, so now you can see I've got all of the data in here. Okay, and I've got all my times, but there's obviously this part of the data where the cart wasn't moving yet. Okay, now before I just start deleting stuff, I actually want to build the graph. Because once I have the graph built, it's much easier for me to see where the data I want is and what stuff I need to delete. All right, so obviously then to build our graph, okay, we click in the top right corner and we highlight everything. Oh, it's hard to do on here. Come on. Two can play that game. Okay, so I'm going to highlight it all, okay, same as we always do to build a graph. Then I'm going to go to Insert, and I'm going to go to Chart. Okay, and Google Sheets actually picked the right kind of sheet. It doesn't always, so if it didn't for you, make sure that up here in Chart Type, you've got Scatter Plot selected, which is down here below the pie charts.
Do we have to go till they're just beside each other in deleting the columns?
Yes.
Or A, B, all the way to A, they're just beside each other?
Make it look like this. Time, position run 1, position run 2. Okay, and then the other columns, just fill them in, like just make blank columns for the rest of the screen, basically. Okay. All right, so now that I've got that, now that I've got the graph, it's pretty clear now which points I don't want to keep. Okay, so for run 1, that's all my blue dots here. I can see that it doesn't even move until well after 1 second. Okay, so I'm going to go back up in my data, okay, right to here, and this is where it looks like it starts, okay, at about 1.3 seconds. So I'm going to highlight all of these, click and drag. I'm going to leave a 0 at the very top. And when you delete these, this is really important, guys, okay? Right click, so for you guys on the touchpad, that's 2 fingers at the same time, okay? So right click in these highlighted boxes, and when it says delete cells, okay, go down here to delete cells, tell it to shift up. That way it'll bring the data from below up, and it won't leave a bunch of blank cells in between, because that really messes up your graph. We want our graph to start at time 0. Okay, so we're going to delete and shift the cells up. Okay, so when I do that, it's going to change how my graph looks. Okay, now my graph looks a bit better. Right, all that stuff at the beginning is gone. Now I need to do the same thing for run 2. It didn't even start moving until 2 seconds. So I'm going to go up here. I'm going to highlight down. All right, so that looks like about where it started there, and do the same thing. Right click, delete cells, shift up. Okay, and when I do that, my graph looks better. Okay, I've still got some stuff here that I could probably get rid of, but I'll get nitpicky later. All right, so now I want to look at the stuff that doesn't count at the end as well. And here's the real trick, guys. If you put your pointer over top of the dots, it'll actually tell you what dot you're on. Okay, so this is telling me that right now I'm looking at this dot right here. Okay, that's probably from there I want to delete onward. So that is at a time of 1.85 seconds. Okay, and the y value is 0.9005. So I want to go to 1.85 seconds and delete everything after that for run 2. Okay, so that's how you can tell which points you need to get rid of, is just hover over it with your pointer and it'll tell you that. So I'm going to go back up here to 1.85 seconds. Okay, so obviously I still have data, but if you look at the data, it makes it look like it's not really moving after that. So I'm going to take from there and delete the rest. Okay, so delete the cells. Okay, all right, so now that looks much better. I could probably still delete those 2 points as well, and I think I will, just because they don't look like they're very nice constant velocity kinds of things. Okay, so obviously yours is going to look a little bit different than mine, and that's okay, right? It's still the same procedure. You just have to look at what you've got and figure out what you need to keep and what you don't need to keep. Okay, I can also see that down here I probably want to get rid of this. So from 0.15 up to 0.15 seconds I also want to get rid of. Okay, so I'm just going to do this and delete those 2 points those 3 points right there as well. Okay, now my line for run 2 looks perfecto. Okay, so that's all you have to do, is just do that bit of manipulating of your data. Okay, that's not bad science. We know what we're trying to keep here. We know what we were trying to do. Okay, so do that for your lines, and then you'll want to put a best fit line in and all that. But it'll get you some time to get it manipulated before I show you how to do the best fit line and the slope and all of that. Okay. All right, so once I've got all the points eliminated that I don't want, okay, then the next thing I want to do, okay, is I want to edit this chart. So I'm going to just go into the chart editor, and I want to go to customize, because I need to get a best fit line on here for each data set, right? So what I'm going to do here is, and it's also in here where I can change things like make sure that I've got a label on the y-axis, because there isn't one, so I would put position in meters. Okay, you do that with chart axis and titles. Okay, and so it's right now it's title text, and I want the axis. So I would go to vertical axis title, and you can type in there position in meters. Okay, and then it'll do that for you. Okay, so now you can see I've got that label there. You can change the title in here as well. Okay, but the big thing is that I need you to go to series, And in here, we want to check trend line. Now, you can also make these points smaller if you want, okay, like I usually do. I usually make them like 2 pixels instead of 7, just because I think it looks neater, but that's totally up to you. You can change the point shape if you want, but we want to put a trend line on here for each data set. Okay, so once I click trend line, then I've got a line of best fit for each data set. I also want the equation for each line. I want Google Sheets to tell me y equals this for each line. So I do that down here. So I have to scroll further down to where it says label. I click where it says none and select use equation. And once I do that, the equations pop up here at the top. Okay, so what this is saying is for run 1, y equals 0.32 times x plus 0.0304. And for run 2, it's y equals 0.561 times x plus 0.0125. Right, so now I've got everything I need from that graph. Right, now I can put both my data and my graph into my lab report. Okay, and that's what I want to do. Okay, so I'm going to first off copy my graph over. So I'm going to go copy chart. And then I'm going to go back to my lab report. And here you can see in data, it says insert your data charts and graphs here. So I'm just going to put my cursor there. And I'm going to paste it in there. It's going to ask me if I want to link it. It's probably best if you do. All right. Now my graph is in my lab report. Okay. It would be also good to have your data charts in there. So that would mean highlighting all of the spreadsheet and throwing it in there as well. Okay. For the analysis, and just so we're clear on what the analysis is expecting, okay, it says build the graph, and then using y equals mx plus b, determine the velocity of both cars. So, all you have to do for the analysis is show me y equals mx plus b manipulated so that it's solving for the speed. You don't need to put in any values. Okay? You don't have to put anything in for y or x. Just manipulate the equation so that it's solving for whatever part of it represents velocity. Put the units on there, and that's it. Okay? Then you can say velocity for run 1 was this, velocity for run 2 was this. Okay? Just show me the algebra. Okay? And if you want to do that on paper and then snap a picture of it and put it in, that's fine too. Okay? Here's the thing. This is getting submitted electronically. I'm not taking any paper from anybody. Okay, so if you do write something on paper, you have to take a picture of it and insert the picture into the document. Okay, everybody clear on that? So that's all you have to do for the analysis. Okay, like it's super simple. Okay, it's not going to take you very long to do that. All right, then you got your conclusion. For your conclusion, copy and paste your hypothesis from above, and then give me an explanation as to whether or not the data in your analysis support the conclusion or support the hypothesis or not. Okay, so you'll have your hypothesis, and then you'll say, in the analysis, the graph had this shape, and the velocity was calculated by doing this, therefore the hypothesis is acceptable. Okay, something like that. And then, for your evaluation, I'm looking for 2 sources of error. So what were a couple of things that could have affected our results? And I would say, look at the shape of the points. Okay, for one of them, the way we did this lab was really not truly a constant velocity. Okay, you can mention that as a source of error. And then anything else that you think was a source of error beyond human error. Okay, do not say, yeah, we screwed up this run and we used it anyway. That you don't want that as the last thing I read on your lab report. Okay, it's, hey, Mr. Coder, I screwed up royally and I did nothing about it because I'm lazy. Okay, you don't want that as the message you want to send me. Okay, so anything that was kind of within the procedure, as I mentioned, this wasn't truly a constant velocity. That's source of error. Okay, what else? Was there anything with the cart, with anything with the track, okay, that could have possibly caused us to maybe not get as good a data as we would have liked? Those are sources of error you could do nothing about. You followed the procedure and it gave you this. Okay, does that sort of make sense? So sources of error and how you would fix them. 2. Okay, questions on what we're looking for? Tom, question?
Do you do a null hypothesis or just?
No. We do not. Okay, any other questions? All right, so you still got almost 20 minutes. Okay, I think you should be able to get quite a bit of that done and not have very much for homework. It is due Friday at 8:30 a.m.